Alright, this is our electrical house project where we will be calculating the monthly cost for 4 houses based on their amount of power usage with like no one in the house.
Alright, so I had house A, and what I did, I used the equation R1 plus R2 equals R total, and I ended up using 1 over 70, which is the resistor, minus 25I, which is the capacitor, and plus 1 over 40, which is resistor 2, and plus 60I, which is the inductor. And then that would equal R total. For R1, I got 70 plus 25I over 1,400 plus 1,750I minus 1,750I minus 625I squared by multiplying both the top and the bottom by the denominator. And my ending equation was 70 plus 25I over 2,025. And then for R2, after I multiplied the top and the bottom by the denominator, I got 40 minus 60I over 1,600 minus 2,400I plus 2,400I minus 3,600I squared. And I ended up getting 40 minus 60I over 5,200. Then I took both the equations for R1 and R2 and cross-multiplied them. After that, I got those equations, added them together, and I divided the ending equation by 1,000, and I got 445 plus 251.5I over 10,530. And then for P, I multiplied that equation by voltage squared, which was 4,400, and I ended up getting 6,408,000 over 10,530, and it equaled 608.5 and so on. And I divided that by 730, and I ended up getting 0.83 and so on. And I multiplied that by the monthly kilowatt charge per hour, and I got 6 cents. And then my ending equation, which was the monthly cost, was 6 cents times X, which is the number of months, plus 4, which is the monthly service charge.
Okay, so I had house B. First, I used the A minus BI equation to find R1. And so I did 1 over 75 minus 20I, because resistor 1 was 75 ohms. And once I did that, I multiplied it by its opposite. And for that equation, I got 75 plus 20I divided by 6,025. And then next, for resistor 2, I did A plus BI. So I did 1 over 55 plus 60I. And then for that equation, I got 55 minus 60I over 6,625. After that, I combined R1 plus R2 to find the total. And I multiplied them by their common denominators. And when I combined them together, I got 828,250 minus 229,000 divided by 39,915,625. I divided each of those totals by 1,000, and then I used the equation to find power, and the equation for that was V squared times 1 over RT. My voltage was 120, so 120 squared was 14,400, and I multiplied it by 828.25 minus 229I divided by 39,915,625. And I got my power equation was 11,926,800 minus 32,976,000 divided by 39,915,625. And then I dropped the I and divided those two numbers and then divided that total by 730. And I multiplied 0.08 times 0.4093154. And then I got 0.03x as my linear equation. And then there's my graph of the equation.
Alright, I had house C, which the resistor 1 was 65 ohms, the capacitor was 30 I ohms, the resistor 2 was 50 ohms, the inductor was 40 I ohms, and the voltage of the house was 120, which seemed to be consistent throughout every single house. The electric company for this house charged 5 cents per kilowatt hour, plus $29 monthly service charge. Alright, so firstly, to find the power, we needed to find the impedance, which is actually the total resistance of the house. But in this case, since we only needed 1 over the total resistance, because the power equation would allow us to just keep it at 1 over the total resistance without having to convert it back to resistance total, we just needed to get the watts of the total resistance, then convert that to kilowatts. Now, since I had already gotten the 1 over RT, we had to convert to kilowatts, which means just divide each value within that by 1,000. Then we would multiply that value by the voltage squared, which is 120 squared, which is 14,400. Which, by the way, at this point, you can actually take out the imaginary number. It's kind of like the fizz within a Coke. It will eventually dissipate within the equation. It'll go away eventually. So you can just take it out of the power, but we'll still treat it as a complex number, even though it's no longer complex. And once we've found that, once we've multiplied by 14,400, we're going to go through and we're going to divide by the denominator, or divide the numerator by the denominator, and we'll get P equals 358 point a very long number, as well as we'll divide that number by 730, which is the industry standard for the amount of hours that are within a month. And when you do that, you'll get P equals 0 point a very long number. Then for the equation, we're going to get the monthly cost, which equals the price times the amount of kilowatt hours that the house used, which is the power that we just found, times the number of months, plus the monthly service charge. Now, for what we got, it was about Y equals 2 cents times the amount of months plus $29. And this is the graph that kind of shows the amount of money that you'd be paying for this house over a 12-month period.
Alrighty, I had house D, and kind of just like everybody else, I used the 1 over R1 and then plus 1 over R2. So first, my resistor 1 was 80, that word, and then my resistor 2 was 50, with a little pump thingy. And then the inductor was 40I, and the capacitor was 25I. As Jen said, our volts were all the same with 120. So I set that up, and then I have to do 1 over 80 minus 20I, and then you're going to do that. To get rid of that, you got to multiply it, you have to have the opposite sign. And with doing that, I'm left with 80 minus 25I over 6,400 plus 625. You add that together, you get 7,025. And then you do 80 minus 25I over 7,000. And that number plus 50 plus 40I over 4,100. And then you have to cross multiply, and then you're left with 351,250 minus 200,081 over a very big number that I can say and then you go to that's your 1 over RT watts, and then you're going to divide everything by 1,000, and then for your power you have 120 squared times 679 and 25 minus 178.50 over 28,802 and 50, and then 120 squared is 14,400 over 1, and then you do that and you're left with 9,781 and 2, and then 2,570, 400, and then 280, 28, 802.50, and that's when you get the power. You do all that. Well, you do that, and then you get P equals 339.60, and then you're going to do that divided by 730, which gets you P equals 0.4 and a bunch of numbers. And then you convert that, and then you plug that into the thing, so you have 0.06 times that number plus the charge, and your equation comes out to be y equals 0.03 times whatever and plus 18. And on my graph, and then you just plug the numbers in for whatever you want to, and it come out to, it worked out perfect for me. I don't know for everybody else, but.
Alright, so these are the graphs that are comparing our different houses and the different prices that we had. And we came up with a short term and a long term, but as we were looking through that, we realized it was only one house that would really fit the bill for both of those. We decided that it was house B because the cost of it was so low, it didn't come with a monthly service charge, and the amount that it would take to go through, or the only other house that sort of competed with it, with the monthly, with the amount of power usage that you're using per month, with how much you're paying for that, was house C, which was about 2 cents plus $29 in monthly service charge. Now, house B was 3 cents, but it would take a very long time for it to catch up and for you to get a profit out of house C.
Alright, and this is the result of using the surf corrector. Don't do that.